Because you were out for a snow day, I wanted you to have the opportunity to see some of these problems worked at your own pace. These are the problems from page 315 that we were looking at that were involving the properties that we learned before the snow day. So I'm just going to walk through. I'm not necessarily going to do all of these. I'm mainly going to talk to you about what property you would use and how to think about each problem. Problem number 33. I think that you can see in number 33, the only thing, let me select a pen here before I get started. In problem number 33, the only thing that's going on here is that the bounds have been reversed. So you're going to turn those bounds around and rewrite it from lower bound 2 to upper bound of 4. And then you can see, and when you change the bounds, when you change direction, you change the sign. So the integral from 2 to 4 of x dx is already given to be 6, and so the answer would be -6. In number 34, we're collecting area from 2 to 2, so we're not making any movement at all. So we know that we collect no area, and the answer would be 0. In number 35, the property that we're looking at there, the 4 coefficient can be pulled out front, and so we have 4 multiplied by 2 to 4 of f of x, that's x, I'm sorry, of x dx, and 2 to 4 of x dx is 6, and 6 times 4 is 24. In number 36, we're collecting area from 2 to 4 of 15. Now remember, that is really the equation of a line, y equal to 15. And anytime you have a constant like that, it's going to create basically a rectangle. Because if you think about it, if you were, let's say that here's my x and y axis, and I'm calling this 15. If I draw the horizontal line, y equal to 15, and I go from 2 to 4, you can see that it's going to form a rectangle that's 15 units tall, and in this case 2 units wide, so 2 times 15 is 30. So it's not really technically a property, but when you have that constant, you have to recognize that what it's really doing, the 15 is telling you the height of your rectangle, and the 2 and the 4 are telling you the width of your rectangle. In number 37, we're going from 2 to 4 of x minus 8. Remember that this would be a horizontal shift, and it's telling you to subtract 8 from every x value. So we're going to go to the bounds, and we'll have 2 minus 8, which would be -6, and 4 minus 8, which would be -4 of x dx. Now you notice that there is no answer for -6 to -4. Alright, let's go back and do a redo on that one. And looking at it again, that's not a horizontal shift, because even though there are parentheses around that, the x is by itself. It's not a 2x or anything like that. So what we can do, that's really the same thing as x minus 8 without parentheses. So instead of being a horizontal shift, it's really a vertical shift. In other words, and I apologize if I confused you here, it's 2 to 4 of x dx. In other words, we can take it apart, minus 2 to 4 of 8 dx. Now remember, this scenario is just like we had in number 36, where we have a rectangle that's going to be 8 units tall and 2 units wide. So 8 times 2 is 16, plus the 6 that we would get from this integral would be 22. All right, let me clear myself a little space here. All right, 38, same scenario. We're going to take this apart, and we're going to rewrite this as the integral of 2 to 4 of x cubed dx plus 2 to 4 of 4 dx. And again, this is your rectangle scenario. It would be a rectangle that's 4 units tall, 2 units wide, so that area would be 8. Number 39, we're going to take it apart. We're going to rewrite the 1/2 in front from 2 to 4 of x cubed dx minus, take out the 3, 2 to 4 of x dx plus 2 to 4 of 2 dx. And I think you can see from up above where you would get your values. And again, this is the rectangle scenario. 2 units high, 2 units wide. The area of that region would be 4. Number 40 is the same thing that we just looked at in the last problem. In other words, we're going to take it apart and integrate 2 to 4 of 6. We're going to pull out the coefficient of 2 and have 2 integration 2 to 4 of x minus 2 to 4 of x cubed. So it is the property that just simply allows you to take the function apart. In number 41, we're dealing pretty much, now this is, number 41 is where, like we did in class the other day, I would make myself a number line with a 0 and a 5 and a 7. And the area from 0 to 5 is 10. The area from 5 to 7 is 3. All right, let's see what we have here. We're looking for 0 to 7 of f of x, so we can see from our number line that that would be 13. In B, we're going from 5 to 0, so we're reversing that. So when you change directions, you change the sign. So if 0 to 5 is 10, then 5 to 0 would be negative 10. Change directions, change sign. Letter C, if we don't make any travel, 5 to 5, we get 0. 0 to 5, we're going to take the 3 out, put it in front. We know that 0 to 5 of f of x is 10, and 10 times 3 is 30. Number 42, again, we know that, let's see if I can squeeze this in here, 0, 3, 6. So 0 to 3 is 4, and 3 to 6 is negative 1. And I just generally tend to put my negatives, here, let's circle these so we don't confuse them with numbers on the number line. I tend to put my negatives on the bottom. So the area from 0 to 6 would be 4 plus negative 1, which would be 3. Letter B, going from 6 to 3, if we change the direction of the bounds, in other words, if we go from 6 to 3, we change the sign of the area, and instead of getting negative 1, my pen has stopped writing here. There we go. Instead of getting negative 1, we get positive 1. Letter C, from 3 to 3, the area would be 0. From 3 to, well, in letter D, we're going to pull the negative 5 out front, so get rid of that. The area from 3 to 6 of f of x is negative 1, and negative 1 times negative 5 is positive 5. Hopefully you're not finding these problems to be too difficult. In 43, we have two different functions. We have an f function and we have a g function, and we know everything from 2 to 6. Letter A, we're simply going to pull it apart and have 2 to 6 of f dx, and I'm leaving out the f of x because of space, and 2 to 6 of g dx. In other words, we're going to have the 10 plus a negative 2, which would give me 8. In letter B, I'm just going to take 2 to 6 of g, which we know from above to be negative 2, minus 2 to 6 of 10, so that would be negative 12. In letter C, we're going to take the 2 off, put it out front. 2 to 6 of g is negative 2. 2 times negative 2 is negative 4. Letter D, we're going to take off the 3, put it out front as a coefficient. 2 to 6 of f is 10, and 10 times 3 is 30. 44, same kind of problem. But no, actually it's not. It's another one of the number line problems. I'm trying to find space to put my number line. So here's negative 1, here's 0, and here's 1. The area from negative 1 to 1, the whole thing is 0. 1 to 0, or sorry, 0 to 1 is 5. So we know that this region has to be negative 5 to make a total of 0. All right, so from negative 1 to 0, we just answered that, is negative 5. from 0 to 1 of f is 5 minus negative 1 to 0, so that would be minus negative 1, so that would be a total of 6. Letter C, we're going to take off the 3 and put it out front. From negative 1 to 1 is 0, and 3 times 0 is 0. Letter D, we're going to take off the 3 coefficient, put it in front. The area from 0 to 1 of f of x is 5, and 5 times 3 is 15. 47 is a geometry problem. In other words, the expectation is that you will find the area of each region. So this is a triangle. It's 2 by 1, and the area of a triangle is 1/2 of the base times the height. So half of 2 is 1 times 1 is 1. However, you got to remember this area is negative because it's below the x-axis. The next region is a semicircle. Notice that the radius of the semicircle is 2, so we're going to do pi r squared over 2. We said the radius is 2. 2 squared is 4. 4 divided by 2 is 2, so this region is negative 2 pi. And finally, we have another triangle, and the base is 1, 2, 3, 4 by 2. 4 times 2 is 16. Half of 16 is 8, so that's a positive 8. So now that I have my areas figured out, I'm just going to answer the questions. The area from 0 to 2 would be negative pi because it's half of my semicircle. The area from negative 4 to 2, yes, positive 2. Negative 4 to 2, that would be a negative 1, negative 2 pi, which is to 2, so that would be negative 1 minus 2 pi. Of course, we can't add that together. Letter E, and I'm going down instead of across. The absolute value of f of x is going to force all of the areas to be positive, so we would have from negative 4 all the way to 6, we would have positive 1 plus 2 pi plus 8, so that would be 9 plus 2 pi as a total. Move that out of the way. 2 to 6, 2 to 6 of f of x is 8. We've already figured that out. From negative 4 all the way to 6, this time we would have all the negative areas would stay negative, so we have negative 1 minus 2 pi plus 8, so that would give me 7 minus 2 pi when I combine my like terms. Letter F, I can take that apart and make it negative 4 to 6 of f of x plus negative 4 to 6 of 2, and that's my rectangle scenario. The rectangle would be 2 units high, and it would be 10 units wide, so that would be an area of 20 added to whatever area I get from the last part from my figure. And finally, number 48, same thing. It's another geometry scenario. The area of this little triangle right here is negative 1/2. The area of this trapezoid, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have 1/2 of 6 because this is 1, 2, 3, 4, 5 for this base, and this is 1, 5, and 1 is 6, and the height is 2. That would be 12, so this area is 6. I just found the area of a trapezoid. You can break it up however you wish. Here I have a triangle, 1, 2, 3, 4, times 2 is 8, half of 8. The area is negative, so I get negative 4. And this little triangle right here has an area of positive 1/2. And from there, you can answer the questions. I think you can see what to do from here. So I'm going to stop there, and then I'm going to come back with another video to look at some of the homework from I think it's page, or the other page that we did using the new way to integrate.